So, how many of you heard of the term machine learning? Okay. How many of you have already worked in machine learning? Okay. So, the session which I am going to take is will be more from applied point of view rather than theoretical, not something that you will find it in a textbook. Whatever you learn, it's in a textbook, but the real world, if you are going to implement, it's going to be totally different from what is available in your textbook. Whatever you learn, the machine learning, the models, it is just 10% of your overall work, but 90% of your actual machine learning involves pulling data from various sources, understanding the business problem, going through the data, generating hypotheses, and then building the model, then deploying the model, then you have to monitor the model. So I will try to cover as far as possible within this 45 minutes. First of all, let's try to understand why do we need machine learning in the first place. So this is a problem. Okay, so you have a ABC Bank. They started operations some 5 years ago, operation a year ago. They have 5 underwriters. So each underwriters, they can process around 200 applications per month. So what happened, before 2 months, this bank has opened a lot of branches. So they started receiving around 1,500 applications. So due to this, there's a huge backlog and obviously increased turnaround time. So what will happen if you have increased turnaround time? Business will move to some other bank. You will be losing business. So how do you think that you're going to solve this problem? So what are the options available to the bank if you have to solve this? First obvious thing is that you can probably hire more underwriters. So underwriters are people who do credit appraisal. So you can put in a lot of people. Otherwise you can automate the whole process. There are 2 ways you can automate the whole process. One, you can use business rules. And the other is obviously machine learning. That's why we are talking about machine learning right now. So what are the problems you will get if you have underwriters? Like first is the cost because you have to recruit a lot of people. And the second issue which you will be getting is there will be no uniformity in appraisal. Like each person will be looking at that particular application, a loan appraisal in a different, because based on this knowledge, he will be doing that appraisal. So there will be no uniformity and there will be a lot of bias also in appraisal process. So if you try to automate it using business rule, the obvious problem is, see, suppose you want to write a business rule. So how will you write a business rule? So if you take an Excel spreadsheet, it will be if and else conditions. Suppose you have 10 variables, you can somehow manage. But still, even if you have 10 variables, the business rules will not have any statistical rigor. So what is meant by statistical rigor? Like you will not be doing any statistical testing on the particular, whether whatever business rules you have is having impact on actual default rates, whether you are able to discriminate between good and bad customers. And another problem you will be getting is, suppose the environment changes, you will not be able to adapt that quickly. And another problem is, like what will happen if you have something like free form text, like a big 10 paragraph text and all. So that will have, like some example would be is background, the particular credit appraisal background, its knowledge of business and all those things. So how do you write a rules for that? For this, you have something called machine learning, which will help you to do that. So this is the definition. Machine learning is a field of study that gives a computer ability to learn without being explicitly programmed. That's okay. We know in the textbook everything is that. So how do we really solve it? So if you have to solve this using machine learning, what you do is you collect the data of all applications. Like you can have various variables, like you can have his age, his credit history, his payment patterns, if you have in the previous banks. So that will be like an independent variable. And in addition to that, variable, you will have something called whether it is defaulted or not. So normally this will be a dependent variable. And you train a machine learning model to discriminate between good and bad customers. So let me give an example, like how the machine learns. Suppose I have a problem, right? Think about this. So 5 means 25, 8 is 64, 12 is 144. What is 10? How do you know that? So that's a pattern you're learning, right? That's how machine learns. So instead of just that 5, 8, 12 and 10 are independent variables, 25, 64, 144 are dependent variables. But here you have only one independent variable. What if you have 50 independent variables? So human mind cannot comprehend and come up with that pattern. And if you come up with a pattern also, it will not be you will not be able to maintain it in the long run. So that's the advantage of having machine learning. So when to use machine learning? Of course, if you have data and if you're possible to collect data only, you should be using machine learning. And if you have complex pattern, if it's simple, then you can use simply if and else condition in Excel to do it. And of course, your solution should require a prediction problem. You should be able to predict. The predict should be useful to the business. Then only you should use machine learning. And then unseen data should have the same pattern as the trained data. That's a basic assumption. And machine learning cannot give 100% accuracy anyway. So your cost of your wrong predictions should also be cheap. And patterns keeps on changing. In that scenario, you can use machine learning. So obvious advantages is it's more accurate than rule-based systems. It's easy to maintain. It can handle large volume of data. It can handle unstructured that we already discussed. So the disadvantages is it's dependent on data. So if your data is not proper, garbage in, garbage out. And suppose you want to derive a ML system. So it may, like for building the model, it may take one month. Then building the data structure will take another 2 to 3 months. So you're going to put 3 months in effort on a particular project, but sometimes you will not be able to get that value out of it if you don't design properly. That's a challenge you are having. And common type of ML task is you have regression and classification. So when you want to predict something, you can predict either a numeric value or a discrete value. So when you predict a numeric value is regression, discrete value is classification. So classification can be binary classification or multiplex classification. So example of binary classification, whether it will default or not, whether it will buy or not. Multi-classes if you have more than 2 labels. So it can be like you are predicting a tweet will be positive, negative or neutral. So this is a basic ML project cycle. First it will come up with problem definition, then you need to convert a business problem into ML problem. Then you have a data collection, exploratory data analysis, feature engineering, model development, validation, model deployment and monitoring. So what we'll do in this session is, I will show you up to model 6 in a notebook. It will be like a more practical also. I'll show you after some time. Once this is, I'll cover a little bit. So first is what is problem definition. So normally before you start building up a machine learning system, you need to understand what the problem is. So you need to talk with the various stakeholders and you should have a clear-cut problem to whether to solve it or not. You have to generate hypothesis, then you have to convert this into an ML problem. So if you want to convert it into an ML problem means, so if it can be either regression or classification problem. Then you have to collect data. Then you need to check whether the problem you're solving, whether there is baseline available or not. See, some of the problems can be solved with business rules also. So if you're going to develop an ML system, your system should be able to perform much better than existing system, rule-based system. And you should be able to automate it, like something if you have a business rule system, say if you have accuracy of 60% and running time of 1 hour, you should be able to give accuracy of 70% with running time of 1 minute. Then only it will be useful. Like that's how we can sell the system. And then for data extraction, you need to develop a lot of ETL jobs and build a pipeline. And then you should ensure that ETL architecture is able to support the production workloads. And what are the columns you are taking? So whatever data you are taking, that should be relevant in a production environment also. And remember, the data which you are going to take, it will all be historical data. So you need to go back in the data, to go back in time to get the data and ensure that it's correct. And if the data is not correct, if you find that after 2-3 months after the model is deployed, when you're going to develop the model, you have to redo it again. So that's challenges in building a machine learning systems. So once we get the data, we have to do EDA. EDA will help us to understand the data, the patterns in the data. You can see what kind of outliers are there, what kind of anomaly is there in your data. So in Python, we'll be using matplotlib, Seaborn, Plotly libraries and all. In R, you can use ggplot. So your EDA can be univariate or bivariate. Univariate is using only one variable. Bivariate using 2 variables. So if it's univariate, probably you can use histogram to get feel of the data, then frequency table. Bivariate, you can use scatter plot. I can use heat map. I will show you in the notebook also. Second is that feature engineering. So once you have a data, it's not necessary that the data will be perfect in your source system. It can have null, like it can have error also. So what you have to do is like you have to handle those null values, your skewness. So normally what happens, right? If you have null values, in many textbooks they will tell you please drop the rows. But what you should ideally do is understand from the source system why the null is actually there. Null will have a business value. You need to go to the source system and check whether what kind of null values are, why null is available. So it will help you to understand the business value out of it. And similarly, if the data is skewed, people say you can do log transformation. But one of the problem with log transformation is how do you ensure that your model interpretation is correct? How do you interpret the models if you have log transformation? How are we going to explain the model but to a business user? Similarly, if you have outliers, we can either consider cap the data, like if you have outliers, probably 99% of the data, 99 percentile of the particular value, you can cap it or insert it. And one more thing, ML models, they cannot accept character values. So you need to convert that into numerical value. So it depends on type of algorithm. You should either use one-card encoding or label encoding or target encoding. There are different types of model. I will come to it. Linear models are more parametric models, statistical models, and tree-based models. You have something like decision tree, random forest. I'll show the demo in that in the notebook also. And for some models, you need the data to be scaled. Scaled in the sense that you need to make that data values into 0 to 1 or -3 to 3, so that algorithm converges correctly. Suppose you're using a gradient descent algorithm, it requires the data to be scaled. And for scaling, for tree-based model, scaling is not required. And you can have And in addition to this, you can have a combination of features as also as a variable. So it will allow your model to improve performance. So these are the important ML algorithms used in various sectors, especially in banking. We have logistic regression, random forest, gradient boosting, and neural networks. So what is logistic regression? Logistic regression tries to draw a line. So it will consider the problem space. So it will try to draw a line to discriminate between good and bad customers, or it will try to draw a line between two classes. So you can see here, right, b plus x plus into v1, it's like an equation of a line. So x1 is actually independent variable, x2 is x1, x2, x3 are independent variable, w1, w2, w3 are a weight of a variable. So how do you learn the weight of the variable? So the weight of the variables are learned by gradient descent. After that you apply a probability. So what I'll do now is, I'll just try to give a demo on a particular problem. So this is a data which I received from Kaggle, which has data of related to banking. The problem is, who will default in next 2 years? That's a problem. So we have this many variables: utilization, age, number of times, debt ratio, monthly income, open credit lines, number of times 90 days late, number of real estate loans, number of 60 days, number of times 60 days past due, number of dependents. So these are the variables. And the serious delinquency in 2 years. We have another variable called serious delinquency, which is a target variable. So what we are trying to do now is come up with an algorithm which will try to predict your defaults. So whenever you are trying to build a model, the first thing you need to do is do a train test split. Why it's required? Whenever you do a train test split, because you're going to train the model on your training data set, and you're going to evaluate and test data set. Then only you will be knowing whether your model is able to generalize to unseen data set. Here, I divided the data set into 70 into 30. So that there are totally around 1 lakh, 5 lakh records. So around 1 lakh records are in training, 45,000 records are in on testing. So this will give you the percentage of defaults. This means around, in a population, around 6.6% of population have defaulted. So there are 1 lakh records, of which around 7,000 records, 7,000 accounts have got defaulted. Next, will give you the correlation between features. I've used Spearman correlation, this will tell you which features are related among themselves. So correlation ranges from -1 to +1. -1 is negative, there's a negative correlation. +1 is they have positive correlation. 0 means no correlation. You can find that certain variables are positively correlated. like number of open credit lines with number of real estate loans. But the problem here is, unless you know the business context of it, you will not be able to interpret it. So basically, this is telling this revolving utilization is your balance by limit. Suppose you take a loan, you have a balance. So balance by limit will give you the utilization. Then you have age, then number of days default, monthly income, all those things. Next, you have unit analysis of an age. For each variable, normally you will be doing this kind of unit analysis. Here you can see that as the age increases, your default rate decreases. You need to take up with the business and check whether this trend is actually relevant to you or not. This is for utilization. As utilization increases, your default rate increases. Similarly, you can use unit analysis for other variables and come up with your final list of variables. This is 90 days slide. If your particular account has become 90 days, even once, it means that it's able to default. So these are the typical steps taken to build a model where you understand the data. So we are in data understanding phases. So this is a biberate analysis where you try to understand more than one variable, number of open credit lines and a number of real estate loans. I think this is taking a lot of time. Okay, I will just comment it. The reason I'm showing this is a feature engineering. And this is cross validation, where I use a training test to understand how good my model is performing in terms of default. Once you do the cross validation, you evaluate on a test data set and your out of time data set. I want to show you the model training. It's taking a bit of time. Let me run it from first. So this is a logistic regression for each independent variable and dependent variable. So for each independent variable, what we do is we multiply that variable with your weights, then apply a sigmoid function, then we will derive the prediction using like you derive the weights using back propagation, and then generate the probabilities. So what is advantage of logistic regression? First, it's easy to deploy the model. So when you're trying to deploy the model, right, you can use this particular logistic regression as if-else statement. You can easily do it. You can easily deploy it, and it's interpretable. Like I can tell you that the age has 2x effect on your default. So that kind of interpretation is available. Simply for decision trees, so this is how decision trees, like this is another class of algorithms which is used. So what decision trees, you try to split the data like a tree. So the topmost part is Pittle width less than 0.8. So you use Gini index to generate optimal splits, and you can see the output that how it's able to differentiate between good and bad. So that's how decision tree is. So random forest is you have multiple decision trees. So each decision tree you will build it on a sample of rows, and also each tree you will be using only sample of columns also to understand so to remove the error. So you will develop multiple trees. Each tree will have only sample of rows and sample of columns, which will allow you to generalize much better. So an average of all predictions considered as the final predictions. Gradient boosting is similar to random forest. First you generate prediction using a single decision tree, then you calculate the residuals, then you train on the residuals, then you run it on using multiple trees. Similarly, you have neural networks. This is a typical neural network. You will have input layer here. This will be your hidden layer. This will be output layer. So each input layer will have weights. You will multiply weights with input layer. You may multiply weights with the variables. You generate then using that weight, you will have an activation function which will allow you will have activation function, and then you have a sigmoid function also. Sigmoid, or this will be your sigmoid or softmax function, which you are able to generate probabilities. Okay. So this is what training a model is. So I divide the data set in k-fold cross validation. I divide the data set into 5 segments. So I train on 4 segments and test on the 5th segment. Like that, I have 5 different folds. These are the AEC score for each folds, and this will tell you, ROC score will tell you how good the particular model is. So it should be either greater than, it should be at least 70. And this will tell you how good your model is. Suppose you want to explain this to the business user. You can see here, like I've sorted the predictions in the descending order. Your total, one second. The lift will give you how much you are performing in terms of random model. So in this data set, we have around 7,000 bad customers, which we have seen in the first segment. So after training the model, in the first decile, we are able to capture around 3,804 bad customers. The second decile, you are able to capture 1,202 bad customers. So what we normally do here is, we take the first decile, and we'll use the first decile for our decision purposes. We'll give more emphasis on this first decile. Suppose real world problem. Suppose in a real world problem, what we'll do is, we'll concentrate on this 10% of customers, and they allow you to capture more than 50% of your default rates. So this is cumulative response percentage. That is, you are able to capture more than 50% of your default rates. And these are the metrics which you will be using. So decile wise, you can see what will be the response rate. So we will be targeting the first decile. Similarly, you evaluate on a test data set, you check what is the performance on the test data set. This will give you which variable is important for your prediction of defaults. So why are we using it? So we need to tie this to our business problem. So this is a common validation matrix like AUC, precision, recall, FN score. Now, this is just a general application. How it's applicable in banking environment. So whatever I told you, right? This is like whatever I told you, this will be applicable in this following use cases. The first is this digital customer onboarding. Like a bank has, they have an application scoring mechanism. Like if a customer comes in, we need to find whether the particular customer is good or bad. How do we find that? So we will have a lot of information will be available, like income, assets, previous loan history, and then we trained a model on that. So we can use any of the model like Logistic Regression, random forest, and then each model will generate a score. Based on the score, we can have a different methodology. Whether we can either we can approve the application, or you can reject it, or you can reject the applications. So I showed you this, right? We can reject this kind of applications. First two deciles we can reject. The next two deciles we can reject. Next two deciles will go for manual underwriter. Next 6 deciles we can give it for direct application processing. Similarly, we can do this for NPA default predictions. instead of you, like if you want to analyze, like if you want to predict who will become default in next 3 months or 6 months, we can use the same kind of applications for that. So the advantage here is you don't need to scrutinize all the applications, all the accounts of the bank. Like suppose you have 10,000 applications, 10,000 accounts. What we can do is probably your model will tell top 30% of the applications. So what you can do is you just concentrate on the top 30% of your applications. So that will allow you to capture more than 60 to 70% of your default. So this will allow you to save your resource cost. You don't need to concentrate on all applications. Not all applications are equal. Second is another application is collection management. Like suppose you want to predict who will not pay the dues in next installment, who will not pay the next installment. So what happens is, if you know that if you're able to identify people who are not able to pay the next installment, your collection efforts can be more focused on those people. So we can either classify customers into high risk, medium risk, or low risk. So you can concentrate only on those high risk persons. You can leave out the low risk person. So this will allow, unnecessarily go and contacting good customers. So you can save your resources. So how do you do that? Similarly, you can have this first 2 deciles as high risk, next 3 years medium risk. That is another application. Second is cross-sell. Like, can you predict who will take our next product in next 3 months? So this will help the bank to generate more revenues. So you can have higher the product per customers, the higher is engagement. So so based on the particular customer's transaction pattern, we can predict who will take the particular product. So this will result in reduction of marketing costs. So you can focus on relevant people with right ads and personalization. Second is the churn prediction. Same. If you can predict who will leave the bank, it will be of much useful to the bank because you can retain good customers. And another application is cash management. Like if you can predict how much of cash is required in ATM or branch, so we can manage cash effectively. So this will be like a regression problem. Another is fraud management. It's like predicting fraud before it actually happened. So it can be either the transaction level or loan account. Why it's required? Because if you have a lot of fraud, it's like a reputation risk to the bank. And second, if you have fraud mechanism, you can identify the fraud before itself. I can do remedial measures on that. Another application is robotic automation. Like banks, they deal with a lot of checks, physical document vouchers and checks. What if you can automate it? Read the checks, automate it, so that your manpower cost will be reduced. You can use deep learning for that. You can use convolutional neural networks for that. And another one is customer satisfaction. Like probably you can have a video analysis of bank CCTV footages. So using the video analysis, you will know like how satisfied your bank customers are, your branch customers are. So it will allow you to identify where the problem is. Like if your particular branch, the people are not happy, you can go to the root cause analysis and get it. So that you can using deep learning and convolutional neural networks. Similarly, you can use natural language processing for customer review analysis, and you can use chatbot for customer queries. So what it actually means for the banks. It will involve better processes. So advantages of ML for a bank is you will be able to manage your customer better. That is one. You can reduce the cost. You can bring in quality customers. You can onboard quality customers. Then you can have personalization. You can manage your resources better. So these are advantages of ML for bank. But to doing all this, the basic is same. You need to have data. You need to know how to manage the data to build a good models. Okay, can I have questions? Hmm. Hmm.
Here, how do you know that a good customer may be rejected because of the algorithm's error, or a bad customer may be in? So those probabilities, how do you compute?
When you have the model will give you the score. The score is based on various variables, like his previous transaction pattern, his behavior with other banks, a bureau score. So the model is trained. What happens is normally when you say something as reject, we'll ensure that at least you are able to capture 80% of bad customer in the reject segment. So that also, and you have 3 tiers: reject, like approved, and then you have manual underwriting. So the algorithm will take care of that. So if it's particular reject, not necessarily he'll be a bad customer, but his chances of becoming a bad customer is more.
In many chat boxes, my experience is chat boxes, not in banking, but in general, they don't answer our query, and they try to reduce their manpower, but the chat box will never answer most of the times. So why it's happening?
So we are not up to that artificial general intelligence level as of now. So when we are expecting that level will come after probably 4 to 5 years. Now there is a lot of it's a lot of improvement in NLP processing chatbot after the transformer architecture has came back, right? Then you have GPT and all, but that's still in work in progress. It will take some 3-4 years to
They
get it.
reduce the background manpower already. That is the problem. But already the manpower has come down, and we have to depend only on this. That is the problem. And how do you prevent fraud? Okay. How does it help AI in preventing fraud?
How does? Mm. So what happens is when you try to what happens is whenever we are trying to build a model, we already have a data of all these frauds. So that fraud, you can probably take it as an anomaly prediction problem. Like if we have group of transactions, like we already have is sitting in gold mine of data, right? If any transaction comes up, any fraud comes up, that can be like it will be like an anomaly detection. That will be shown as unique. That doesn't follow the regular pattern. The algorithm will be able to tell you whether it's regular or not regular, so that it will be able to understand the frauds.